Hello, my name is Tina DiClemente. I retired from teaching science and chemistry with the Halton Catholic District School Board in 2016. As a retired teacher, I decided to get involved in the climate movement, and so I joined Hamilton 350. After attending several meetings, I met some other members and we decided to form a subgroup called Elders for Climate Sanity. From there, we put together a slideshow that we took to different groups such as retirement homes, churches, clubs, and classrooms. When the COVID crisis hit, it brought all that work to a grinding halt. So we are putting together this video. Hopefully, it will be useful to you. At some point, we want to get back on the road and visit your group.
We always like to start our presentation with a land acknowledgement. We are gathering on the traditional territories of the Haudenosaunee Confederacy and the Mississaugas of the New Credit. This land remains subject to the Dish with One Spoon Wampum, an agreement to ensure that all will share the earth. Each can take what they need, but only what they truly need. That way, we will all have something for the 7 generations to come. This is a picture of my textbook from the 1980s when I started teaching chemistry at a Catholic secondary school in Burlington. This book was published in 1988. I recently took a look at that book again, and sure enough, there's a whole section on climate change. Here is an excerpt from that book. Since it is believed that the Earth should warm by 0.1 degrees Celsius for each 10 parts per million increase in CO2 concentrations, the global temperature could rise by 3 degrees Celsius by the year 2050. All these years have passed since 1988, and I am astounded at how accurate that line was from the textbook. We have known about this problem for quite a while. I've been following the climate movement for over 30 years. I've taught it in school, and I ran the Environment Club too. I was disappointed with the lack of serious attention this issue received during my entire teaching career. After I retired in 2016, I started giving up hope. I was reawakened when I saw this article that came out in October 2018. This was the first time I thought scientists were kind of freaking out. It basically said we have 12 years to avoid a climate catastrophe. I thought I have to get involved again, and here I am. What are the scientists predicting? This graph shows temperature on the y-axis and time on the x-axis. We can see there has been a slight warming since 1900 to today. Let's imagine a child is born in the year 2020. What kind of future will that child have? Scientists say if we do nothing at all, we just carry on as business as usual and keep burning those fossil fuels like there is no tomorrow, then the graph shows that the child is heading into a world that goes into the red zone, where by the end of the century, it could be anything from 3 to 5 degrees warmer. If we are at 4 degrees warming, that's where we may see the breakdown of human civilization as we know it. The Paris Agreement tried to get countries to commit to not going into that red zone. Back in 2015, they thought we should go no higher than 2 degrees. But in 2018, they said that a 2-degree world is too catastrophic, so we are trying to go no higher than 1.5 degrees. And that's represented by the blue section of this graph. Thanks. A year later, in 2019, 11,000 scientists signed this petition and warned again of untold suffering if we do not get our act together. Basically, they said in that report that to secure a sustainable future, we must change how we live. CO2 levels. Carbon dioxide is a gas that is a product of burning fossil fuels like coal, oil, and natural gas. The Industrial Revolution started around 1750 when we started to burn coal. In 1750, the CO2 level in our atmosphere was about 280 parts per million. What that means is that for every million invisible molecules of air that you can imagine, 280 of those million are carbon dioxide molecules that are naturally there. Now, 280 may not seem like a lot, but it is a lot, because if you were to remove them, the average global temperature would be minus 18 degrees Celsius, and the Earth would be an ice ball. Thank God they are there, so that we have a livable planet. Scientists are saying that we should not go higher than 350 parts per million. That is why the 350 climate movement uses that number. Do you know what the current CO2 level is? Well, if you don't know, I'm going to tell you. At the beginning of 2020, CO2 was about 412 parts per million. We are well beyond the safe level of 350. In fact, in April of 2021, for the very first time, CO2 went above 420 parts per million. The levels fluctuate throughout the year, but the trend is the average goes up by 2 to 3 parts per million each passing year. So what has happened since we have gone from 280 to 412? What has happened to our Earth? The average global temperature has risen nearly 1 degree Celsius since the Industrial Revolution, from 14 degrees to 15 degrees. Some of you will think that that does not seem like very much warming at all, so why should we care? I will show you later in the presentation a 1 degree warming represents a lot of heat. This graph comes from NASA. It shows in the last 800,000 years that carbon dioxide levels have never gone higher than 300 parts per million. That's the horizontal line. But look at where we are now. The current level, we are in uncharted waters. For those of you who may not know how the greenhouse effect works, I have put into the presentation this excellent 5-minute video produced by the University of Waterloo's Perimeter Institute. The Perimeter Institute is a world-class center of study. Even Stephen Hawking was there as a distinguished visiting research chair. I find it very interesting that the Perimeter Institute put out this video in November of 2018, 1 month after the alarming climate scientist report that stated we have 12 years to drastically bring down our CO2 levels.
Stop it.
Our planet's atmosphere has been warming recently, and the cause is something called greenhouse gases. But what exactly are greenhouse gases, and how do we know they cause our planet to warm up? The objects on this table are at room temperature, each more or less as warm as the objects next to it. But some things are warmer than others, like this cup of tea. Because the cup of tea is warmer, energy is flowing from the tea to the room around it, in the form of infrared radiation. By using an infrared camera, we can watch the cup of tea cool as it transfers energy to the room. Over time, it will reach the same temperature as the other objects around it. In science, this transfer of energy is what we call heat. Now, let's step back and imagine our planet. Our sun is continually transferring some of its energy to our planet. Much of that energy travels right through Earth's atmosphere and reaches the surface, where it is absorbed and re-emitted into the atmosphere in longer infrared wavelengths. If all of that energy passed through the atmosphere directly into space, our planet would be quite cold, on average around minus 18 degrees Celsius. But infrared energy can interact with certain gases in the atmosphere, which are known as greenhouse gases. These gases interrupt the flow of energy escaping from Earth, holding some of that energy in the atmosphere. It is a little like throwing this towel over this heating pad. The towel interrupts the flow of heat, trapping the energy near the surface of the pad. A simple experiment will demonstrate which atmospheric gases behave in this way. Here are 4 cylinders filled with 4 atmospheric gases: nitrogen, oxygen, carbon dioxide, and methane. Notice the gases are transparent to visible light, just like the atmosphere. But in this experiment, we'll test which ones are transparent to infrared light. This heating pad emits infrared wavelengths and will simulate our planet's surface. We've sealed the ends of each cylinder with thin plastic wrap, because glass itself blocks infrared radiation, but the thin plastic doesn't. We'll start with a cylinder filled with nitrogen gas and place it between the infrared camera and the heating pad. Looking down through the cylinder, we notice that the infrared energy passes right through nitrogen without being absorbed. If we try the cylinder filled with oxygen gas, we get a similar result. But carbon dioxide is a different story. Notice how the image in the infrared camera becomes much cooler. This reveals that the carbon dioxide is absorbing some of the infrared energy given off by the heating pad before it can reach the camera. And here is methane. Methane also absorbs the infrared radiation. So, greenhouse gases, like carbon dioxide and methane, are gases that absorb energy, trapping more energy in the atmosphere. But to see if greenhouse gases actually behave this way in the atmosphere, we have to move from our tabletop experiment to the real world. The first piece of evidence comes from a satellite measuring the wavelengths of infrared energy escaping from Earth's atmosphere. Since the precise wavelengths absorbed by each greenhouse gas are known, the satellite should detect gaps at those precise wavelengths. This curved line shows what would be detected if no gases were absorbing energy. And this squiggly line shows the real measurements from the satellite. The difference between the curved line and the squiggly line reveals the energy being absorbed by greenhouse gases. These wavelengths here are missing because of carbon dioxide, and this dip is caused by methane. And these gaps show wavelengths absorbed by water vapor and ozone, 2 other important greenhouse gases. This is the energy that doesn't escape through the atmosphere and remains behind to warm the planet. Next, we have to see if a change in the amount of greenhouse gas in the atmosphere causes a rise in global temperature by looking at things over time. Here is a chart that shows a 40% rise of atmospheric carbon dioxide over the last 60 years. And here is a chart that shows global temperature over the same period. The average surface temperature of our planet has been rising at the same time as we've been putting more and more greenhouse gases, like carbon dioxide, into the atmosphere. So, given our little experiment and the evidence from real-world measurements, it is very difficult to ignore the fact that greenhouse gases are causing our planet's climates to change. And once we realize this, we have to ask ourselves, what are we doing about it?
I would like to go through a brief history of global warming, a topic that has been around for over 100 years. In 1859, the British scientist John Tyndall demonstrated in front of an audience of other scientists that carbon dioxide gas has the ability to absorb heat in the form of infrared radiation. So that is a simple fact no one can dispute. Then in 1896, the great Nobel Prize-winning Swedish chemist Svante Arrhenius wrote the first scientific paper that correlated rising CO2 with a warming planet. In 1958, Charles David Keeling started to directly measure what the carbon dioxide levels are in our atmosphere in real time. We should not just rely on ice core data or tree ring data, which are called proxy measurements. Keeling picked Mauna Loa in Hawaii because that is where the air is as clean as possible, away from industry, away from cars. The collection of this data started in 1958. In 1958, the CO2 level was about 315 parts per million, and it has been rising relentlessly ever since. Now, I was born in 1958, and in that year there was a television program called the Bell Telephone Hour. I was astonished to learn this program actually ran a documentary on climate change back in 1958. I'm going to play a minute of this documentary.
Extremely dangerous questions, because with our present knowledge we have no idea what would happen. Even now, man may be unwittingly changing the world's climate through the waste products of his civilization. Due to our release through factories and automobiles every year of more than 6 billion tons of carbon dioxide, which helps air absorb heat from the sun, our atmosphere seems to be getting warmer.
This is bad?
Well, it's been calculated a few degrees rise in the Earth's temperature would melt the polar ice caps. And if this happens, an inland sea would fill a good portion of the Mississippi Valley. Tourists in glass-bottom boats would be viewing the drowned towers of Miami through 150 feet of tropical water. For in weather, we're not only dealing with forces of a far greater variety than even the atomic physicist encounters, but with life itself.
The next significant historical moment happened in 1965. President Johnson was the first president to be concerned with what we are doing to our environment. He commissioned a team of scientists to put together a special report called Restoring the Quality of Our Environment. And in that long report, there is a section specifically on climate change and how rising CO2 levels can dangerously warm up the Earth. In that same year, the American Petroleum Institute had their annual conference. The president of the American Petroleum Institute at that time, Frank Ickard, actually acknowledged the rising of CO2 from the burning of fossil fuels. And this is what he said at the conference. Pollution from internal combustion engines is so serious and is growing so fast that an alternative non-polluting means of powering automobiles, buses, and trucks is likely to become a national necessity. It is astounding the petroleum industry acknowledged the problem in 1965, but sadly, very little action resulted. The next important piece of history came in 1988 when James Hansen, probably one of the world's most famous climate scientists, testified about global warming before a U.S. Congress. And this is what he said. The Earth is warmer in 1988 than at any time in the history of instrumental measurements. There is only a 1% chance of an accidental warming of this magnitude. The greenhouse effect has been detected, and it is changing our climate now. Because of this warming, the United Nations put together the IPCC, the International Panel on Climate Change. The IPCC is made up of thousands of scientists who actually do not do research. What they do is gather and study all the climate research being done throughout the world. Then they write summary reports based on that research to give a clearer understanding of how global warming is affecting the Earth. These reports then get passed on to government officials who don't like to recognize that this is a serious problem, and they often tone down the language of the scientists. So after reviewing this brief history of climate change, the big question to ask is, why have we been ignoring global warming or climate change for many decades? I think there are two major reasons for this. The first deals with the scientific process. In other words, how science works. Richard Feynman is considered one of the greatest scientists of the 20th century. Sheldon on The Big Bang Theory has referenced him a number of times. Feynman's quote, which I'm about to show, explains a very fundamental truth underlying all scientific work. Scientific knowledge is a body of statements of varying degrees of certainty, some most unsure, some nearly sure, but none are absolutely certain. There is no perfection in science. I learned this during my first year as a chemistry student at McMaster University. Every measurement we made had to have a range of uncertainty. For example, the temperature of a solution could be 22 degrees Celsius, but with that temperature was attached a plus or minus 1 degree Celsius. The perfect temperature was somewhere between 21 and 23 Celsius, but no thermometer in the world could ever determine that perfect value, no matter how much money you spend. Thus, every measurement has a degree of uncertainty, but that doesn't mean science is completely out in left field. We know the temperature is about 22 degrees. It's not 53 degrees or negative 14 degrees. Science cannot perfectly measure mass or volume or electrical current or anything at all, but science can still know a lot about our physical world. Today, we still don't know exactly what gravity is, but we obviously know enough to put people on the moon. Throughout the COVID-19 pandemic, we have come to better see how science works. It needs to collect lots of data before it can have an accurate understanding of reality. But it can never be perfect, just like a vaccine cannot be 100% effective at stopping a COVID infection. Now, why is this important? It's because the fossil fuel industry has magnified the fact that science can never be perfect. This is a statement that was found in a 2002 ExxonMobil memo. You need to continue to make the lack of scientific certainty a primary issue in the debate. And that's a picture of where that statement was taken from in the memo. The idea of creating doubt in science is a very old strategy that goes back to the tobacco industry. Merchants of Doubt is a book that traces this horrible strategy used by industry to keep profits up at the expense of public health. It took decades for science to come up with enough evidence to finally convince the public that cigarette smoking can lead to respiratory disease. This strategy of doubt in science has been used to promote the use of asbestos and ozone-destroying chemicals. Now, for decades, it has been used by the fossil fuel industry to deny climate change is real. If you want to better understand how the world of money runs our lives, I recommend reading Dark Money by Jane Mayer. This book lists a number of organizations that have major influence on our political system so that the fossil fuel industry can keep being subsidized and growing. They all have promoted doubt in climate science. I put this cartoon into the presentation because I firmly believe that if one has enough money and power, the average citizen can be made to believe just about anything. A good example of this occurred in 2003 when the USA decided to bomb Iraq because it was stockpiling weapons of mass destruction. It was the big lie needed to invade a country with rich oil reserves. In the end, there were no weapons of mass destruction to be found. In 2015, a team of journalists published a piece that revealed how Exxon knew that climate change was real, even though they played up climate science doubt. Here is a sample from this Pulitzer Prize finalist report.
Proponents of the global warming theory say that higher levels of greenhouse gases are causing world temperatures to rise and that burning fossil fuels is the reason. But scientific evidence remains inconclusive as to whether human activities affect the global climate.
We found a trail of documents that go back to 1977. Exxon knew carbon dioxide was increasing in the atmosphere, that combustion of fossil fuels is driving it, and that this posed a threat to Exxon. At that time, Exxon understood very quickly that governments would probably take action to reduce fossil fuel consumption. They're smart people, great scientists, and they saw the writing on the wall.
We were collecting data of the southern Atlantic, the Gulf of Mexico, and the western Indian Ocean. Basically every hour we would get several measurements, so we had, I called it a data monster. We were committed, we were doing some serious science. It was a significant budget, I would say on the scale of $1 million a year. And that was a lot of money in 1979. We were generating what we thought was state-of-the-art information. We were doing science that we didn't think in any way, shape, or form would be questioned. And there was no questioning that the atmospheric carbon dioxide was increasing, that atmospheric carbon dioxide was going to change the climate in some fashion. The question was how fast, how much, and what kind of impacts would it have, overall to the planet.
I think all of this is surprising, given what Exxon started to do in the 90s.
Many scientists agree there's ample time to better understand climate systems and consider policy options. So there's simply no reason to take drastic action now.
They claimed that there wasn't enough science to back any kind of decision to reduce carbon emissions from the combustion of fossil fuels, when in fact, by the time they started staking out that position, they'd known the science for probably about 15 years, if not longer. They ended up instead leading the denial and clouding of public perceptions of science. I mean, the change is amazing, and that story is what's not known.
Imagine all the greenhouse gases that have been emitted since 1750. Over half has been emitted in the last 30 years. What did the fossil fuel industry do 30 years ago? It promoted doubt in science to confuse the public about global warming. How science works. Peer review is used to ensure quality and integrity. Science is a self-regulated system that is constantly undergoing revision. It is the best tool we have to determine what is true and not true. I remember going to school one day in March of 1989. All the newspapers were reporting that a team of scientists had found the holy grail of energy production by discovering cold fusion. Our sun is fueled by fusion. The claim was that science could now essentially replicate the power of our sun in a reasonable fashion. Scientists all over the world tried to repeat this process that was published by the scientific team. Nobody could do it. After 1 month, the New York Times declared this story dead. The message here is that we don't need bloggers or social media to find out whether science is solid or not. Science itself regulates what is real and what is not real. Here's a video to describe how science works.
And when you have people who don't know much about science, standing in denial of it, and rising to power, that is a recipe for the complete dismantling of our informed democracy. One of the great things about science is that it is an entire exercise in finding what is true. You have a hypothesis, you test it, I get a result. A rival of mine double checks it because they think I might be wrong. They perform an even better experiment than I did and they find out, hey, this experiment matches. Oh my gosh, we're onto something here. And out of this rises a new emergent truth. It does it better than anything else we have ever come up with as human beings. This is science. It's not something to toy with. It's not something to say, I choose not to believe equals MC squared. You don't have that option. When you have an established scientific emergent truth, it is true whether or not you believe in it. And the sooner you understand that, the faster we can get on with the political conversations about how to solve the problems that face us. So once you understand that humans are warming the planet, you can then have a political conversation about that. You can say, well, are there carbon credits? Do we do this? Do we put a tariff on it? Do we fund? Do we subsidize? Those have political answers. And every minute one is in denial, you are delaying the political solution that should have been established years ago. As a voter, as a citizen, scientific issues will come before you. And isn't it worth it to say, all right, let me at least become scientifically literate so that I can think about these issues and act intelligently upon them. Recognize what science is and allow it to be what it can and should be in the service of civilization. It's in our hands.
The second major reason why I think the general population does not believe in a warming planet has to do with the nature of water. About 70% of the Earth's surface is covered by liquid water, mainly our oceans. Liquid water has a very high capacity to store heat with a minimal rise in temperature. Water is about 10 times greater in its ability to store heat compared to most metals and 5 times greater than soil, sand, or air. You experienced this fact when you were at the beach on a hot summer day. The sun is beating down on the sand and your feet get so hot that you look for relief. So what did you do? You didn't jump on a metal bench because that would make your feet even hotter. Instead, you ran to the water. Even placing your feet in an inch of water cooled down your feet. But you never stopped to think why? Why are the sand, the metal bench, and the water all at different temperatures when the sun is sending the same amount of heat to all these substances? The answer is because a lot of heat is needed to raise the temperature of liquid water. So now we come to the big question, especially for deniers of climate change. Where is all this global warming on our planet to be found? This graph illustrates that most of the heat trapped by greenhouse gases is absorbed by the oceans. The blue section of the graph shows that over 90% of the extra heat the Earth is trapping is ending up in the oceans. The rest goes to land, the air, and the melting of glaciers and ice. To drive this important point home, I would like to conduct a simple experiment.
All right, this balloon is filled with air, and we know that air does not have a very high capacity to store heat. This means that it will take very little heat to raise the temperature of the air inside the balloon. We're going to apply flame to the balloon, And when the temperature goes up rapidly, it will reach the melting point of the latex rubber and the balloon will pop. We've seen this many times. Okay, let's do that. I'm gonna just light this candle flame. Woo! Okay. All right, this time now, I've got a balloon filled with water. I want you to think of this balloon as our planet Earth, the big blue marble. Remember, 70% of our planet is covered in water. Now, when we apply the flame this time, let's see what happens, because we know that water has a very high capacity to store heat. Now, it has been calculated that the amount of heat that our oceans are accumulating is equivalent to 5 Hiroshima atomic bombs exploding every second. And that's been happening for the last 25 years. And the temperature of the water hardly rises. This explains why it is difficult for us to feel global warming all the time. Okay, I'm just going to stop that. In fact, we've had somebody hold this balloon for as much as 30 minutes, and you can try this at home if you want to prove that point. Okay. The real furnace of our world is found in the oceans. The oceans and wind are responsible for driving the weather we experience all over the world. We are pouring all this extra heat into this ocean furnace, and this hidden heat travels all over the world to give us more extreme weather events and eventually climate breakdown. When the USA declared Iraq was stockpiling weapons of mass destruction, it was looking in the wrong place. The weapons of mass destruction are accumulating in our oceans in the form of heat. Compared to our massive oceans, our atmosphere is very thin. Since 1750, all the greenhouse gases have trapped enough heat to raise our average global temperature by 1 degree Celsius. But what if there were no oceans? What if all the extra heat was trapped within our thin atmosphere? What temperature increase would we experience then? 36 degrees Celsius. Add that to the average global temperature of 14 degrees Celsius before the Industrial Revolution, and the new average would be 50 degrees Celsius. No one could even try to deny global warming because we would all be dead. It is my hope that this presentation has helped you better understand why it is so difficult for an individual to notice our warming planet. Weather and climate are complicated things for the average person to fully understand. But one thing we know for sure is that our global ocean furnace is heating up dangerously. The COVID-19 pandemic has given us a rare opportunity to see how the entire world is affected by a global crisis. There are many similarities between the pandemic and the climate crisis. The next slide will show a few of these similarities. The pandemic will end one day. However, one big difference is that the climate crisis will lead to a permanently altered planet. This will have a far greater impact on human civilization and all living creatures. We hope the pandemic has taught us some important lessons as we strive to stave off an increasingly warmer world. You can't negotiate with a virus or a CO2 molecule. They follow the laws of nature. As much as we want to exercise our freedom to live any way we want, the virus or CO2 molecules simply don't care. They just do what they are designed to do: infect people and trap heat. It's all a hoax. Even in the pandemic, there are voices of doubt in science. I personally know people who refuse to wear a mask because they believe COVID-19 is no worse than the common flu. It is convenient to believe the climate crisis is a hoax because then we can continue to enjoy the benefits of burning fossil fuels with no sense of worry or responsibility for our actions. Cracks in our system are revealed. The poor and marginalized suffer the most. Even though experts warned a pandemic was coming, we were simply unprepared for it. There was a worldwide shortage of PPE for our healthcare workers. There were not enough ICU beds or ventilators or even oxygen supplies in some cases. It's like the near future isn't even on the radar when it comes to how we govern ourselves. The crisis revealed the huge gap between rich and poor. Big corporations like Amazon and Loblaws profited from the crisis while many small businesses lost everything. Many frontline workers got sick with COVID because they did not have paid sick leave. This led to the virus further spreading and causing more deaths. The climate crisis is playing out in the same manner. Millions of migrants are leaving their homes because a changing climate has led to things like water scarcity and the inability to grow food. As resources dwindle, violence within communities grows and people are forced to flee. This will only get worse as the planet continues to warm. Many Ontario cities, like Hamilton, declared a climate emergency in 2019, but very little has materialized to address this crisis. Pretending these problems don't exist will only lead to chaos and greater harm to those who are poor and marginalized, and eventually even the rich will suffer. There are so many more specific examples to show how a crisis reveals the gap between rich and poor. I encourage you to raise these examples in your group. Many refuse to take any responsibility for their actions. Just as in the pandemic, there are some who refuse to follow public health guidelines. In the climate crisis, there are some Canadians who claim that Canada is only responsible for 2% of global emissions, so we don't need to change our ways. Instead, they point to countries like China or the USA that emit far more. But per capita basis, China emits far less greenhouse gases compared to Canadians. But more than this, the pandemic has taught us that every person matters to keep the virus from spreading. If we are going to tackle the pandemic or climate change, everyone needs to play their part. Ultimately, the solution depends on human behavior. We want to believe that technology or a vaccine will solve our problems. If only it were that simple. When I was in grade 12, my English teacher gave me the chance to rewrite an essay. The topic was Discuss the Theme of Restraint in Heart of Darkness by Joseph Conrad. As a high school kid, I did not understand the significance of that essay topic. In light of today's challenges, I get it now. Bill McKibben is a co-founder of the 350 movement. In his latest book, Falter, he writes a lot about human restraint. He imagines a thriving world where people are satisfied with smaller homes and a solar panel on the roof to meet all their basic needs. This kind of simple living requires a limit on our wants. It requires restraint. It requires a change in human behavior. I am not sure if human restraint can be practiced on a global scale, but one thing I know for sure is that sooner or later, the natural world will dictate how we live our lives. We can choose to not wear masks and party hard, but eventually so many of our loved ones will pay the price of death for such behavior. It could easily lead to the collapse of our entire healthcare system. Who wants to be an ICU nurse in such a careless world? With the climate crisis, droughts, shortages of food and water, wildfires, floods, etc., will eventually force humans to live differently. We want to believe that we are in complete control of our lives, but the reality is that nature bats last. We are learning that lesson the hard way. The pandemic and climate crises force us to ask core questions such as, who are we as human beings? Who do we want to become? Where do we find hope? After many years of my involvement with the climate movement, this is the best definition I have found to help guide us through this situation. Hope lies in those who will act to do what is right, no matter how things turn out. This next video is a great example of how we can be hopeful through action.
This is not a drill. My name is Greta Thunberg. We are living in the beginning of a mass extinction. Our climate is breaking down. Children like me are giving up their education to protest. But we can still fix this. You can still fix this. To survive, we need to stop burning fossil fuels. But this alone will not be enough. Lots of solutions are talked about. But what about a solution that is right in front of us? I'll let my friend George explain.
There is a magic machine that sucks carbon out of the air, costs very little, and builds itself. It's called a tree. A tree is an example of a natural climate solution. Mangroves, peat bogs, jungles, marshes, seabeds, kelp forests, swamps, coral reefs, they take carbon out of the air and lock it away. Nature is a tool we can use to repair our broken climate. These natural climate solutions could make a massive difference.
Pretty cool, right?
But only if we also leave fossil fuels in the ground.
Here's the crazy part. Right now, we are ignoring them. We spend 1,000 times more on global fossil fuel subsidies than on natural-based solutions.
Natural climate solutions get just 2% of all the money used on tackling climate breakdown.
This is your money. It is your taxes and your savings.
Even more crazy, right now when we need nature the most, we're destroying it faster than ever.
Up to 200 species are going extinct every single day.
Much of the Arctic ice is gone. Most of our wild animals have gone. Much of our soil has gone.
So what should we do?
What should you do?
It's simple. We need to protect, restore, and fund. Protect. Tropical forests are being cut down at the rate of 30 football pitches a minute.
Where nature is doing something vital, we must protect it.
Restore. Much of our planet has been damaged.
But nature can regenerate, and we can help ecosystems bounce back.
Fund.
We need to stop funding things that destroy nature and pay for things that help it.
It is that simple. Protect, restore, fund.
This can happen everywhere. Many people have already begun using natural climate solutions. We need to do it on a massive scale.
You can be part of this.
Vote for people who defend nature.
Share this video. Talk about this.
All around the world, there are amazing movements fighting for nature. Join them.
Everything counts. What you do counts.
I hope your group learned a few things and, more importantly, feel inspired to participate in some hopeful actions. If you wish to discuss the presentation further, some discussion questions have been provided. 1. How did you feel when you learned that the fossil fuel industry deliberately downplayed the seriousness of climate science? 2. How do you decide what is true and not true? Where do you get your information from? 3. How will future generations look upon us? When I used to teach grade 10 science, I used to show a video that showed DDT being sprayed on children at swimming pools. And the kids in my class used to laugh when I showed this video from back in the 1950s. But I would always stop the video at that point and I would ask them, you know, you're laughing at that behavior, but what are we doing today? That 50 years down the road, people who are looking at us are going to be laughing at us, maybe even crying, because we were doing things that were just so stupid. Anyway, I encourage you to think about question 3. 4. Can you think of more similarities between the pandemic and the climate crisis? 5. What actions can you take to help nature? And 6. What actions can you take to put more pressure on our leaders? Thank you for your time and attention.